Hello everyone, a very warm welcome to the teaching show. In this video, we are going to study how to make use of STP condition in order to solve any numerical and what are SCMH flow rates and how do you find meaningful information if these flow rates are given. Okay, so let's get started. So first of all, I will give you a brief recap. PV equal to nRT, that is your ideal gas law. And we said that if you fix pressure and temperature and also the number of moles, then your volume automatically gets fixed. Okay, so that's what we are doing. When we say STP conditions, what we are saying? Standard temperature and pressure conditions. So we have fixed standard pressure at 1 atmosphere and standard temperature at 273 Kelvin or 0 degree centigrade. Further, we are fixing number of moles equal to 1 mole. For that, if we calculate the volume for any ideal gas, it will come out to be a constant, that is 22.4 liters. If you are taking 1 kilomole of number of moles as number of moles, then your volume is in meter cube, that is you can write it as 22.4 meter cube. Okay, so remember this, 1 mole 22.4 liters multiplied by 1000 multiplied by 1000. 1 kilomole, that is equal to 22.4 into 10 raised to 3 liters, which is nothing but 22.4 meter cube. Okay, so these are your standard temperature and pressure conditions. In short, we call them as STP. Okay, so now we will solve a problem which is based on STP condition. This is a problem which I have taken from Felder. It is unsolved problem 5.12. Okay, so the problem description is given in the description box. The whole statement is given in the description box, but I am going to explain the problem to you before solving it. Okay, so I have a container which is a rigid container, so its volume is fixed. Okay, these are 3 conditions. Okay, I don't have 3 containers, it is 1 container. First of all, I am filling it with nitrogen and weighing. So I find that once I fill this container with nitrogen, its weight is 37.289 grams. Then next what I do is I fill this same container with carbon dioxide and measure its weight. Its weight is found to be 37.440 gram. Then I fill the same container, remove CO2, fill the same container with an unknown gas and find out the weight of the container plus the gas, which comes out to be 37.062 gram. So all these weights which I have written over here, M1, it is weight of container plus weight of nitrogen gas. This is weight of container plus weight of CO2 gas. This is weight of container plus weight of unknown gas. Okay, so I have weighed the container. Further, the problem tells you that this gas is at STP, that means it is at standard temperature and pressure of 0 degree centigrade and 1 atmosphere. Okay. Now they are asking you to calculate what is the molecular weight of this unknown gas and if you can identify which gas this is. Okay. So let's get started. So we are assuming that this is an ideal gas. I can write ideal gas equation for each of the case. When the container is filled with nitrogen, I write it down as PS, that is standard pressure, into V. Because this is a rigid container, V remains constant, is equal to N1, that is the number of moles of nitrogen in this tank or in this container, multiplied by R times TS. TS is the standard temperature. Okay. For the second case, when the container, it contains carbon dioxide, then I write PSV is equal to N2RTS. So the only difference is in the number of moles. Okay. Similarly, I am writing it for the third case. Now, if I divide this equation by this equation, your pressure is same, it gets cancelled. Volume is same, it gets cancelled. R is a constant. TS is again same, so it gets cancelled. So I end up with N1 by N2 is equal to 1, or that means N1 is equal to N2. If I do the same thing with second and third equation, I get equation as N2 equal to N3. So what do I get? I get that N1 is equal to N2 is equal to N3. Okay. So this is what I have got from the ideal gas equation. Now further, in order to solve this problem, I have to find out what is the weight of the container. Okay. Because if I have to find out what is the weight of the gas which is there, I have to subtract the weight of the container from this total weight. Okay, so let us call the weight of the container to be m. Fine. So then the weight of nitrogen gas in the first case will be 37.289, that is the combined weight, minus the weight of the container. Okay, and if I want to find out how many number of moles of nitrogen are there, then I have to divide the weight of the gas by its molecular weight. So molecular weight of nitrogen is 28, so I divided by 28. So this gives me number of moles of nitrogen gas in the cylinder. Similarly, the same thing I am doing for carbon dioxide. Combined weight of container plus CO2 gas minus the weight of the container divided by the molecular weight of CO2, which is 44. The same thing I am doing for the unknown gas. So the combined weight minus the weight of the container divided by the molecular weight, which I don't know, so I am writing it as a variable m. Okay. Now I have written the equation. So these are two equations basically. Okay. So first I am going to solve this equation. So if I solve this equation, this divided by this equal to this divided by this, it's an equation in only one unknown. So I can solve this and find out the value of m. So mass of the container, it is found to be equal to 37.02475 grams. Okay. So I have used this equation and calculated the mass of the container. Now I know the mass of the container. Okay. Next step will be to find out the molecular weight of the container. So next step is to find out the molecular weight of the container. Now I am going to solve this equation. Okay. Now I know what is m. The value of m I have calculated. I will use this equation and calculate my molecular weight. If you do so, your m will come out to be approximately equal to 3.96 or close to 4. Okay. So which gas this will be? The 4 is the atomic weight or molecular weight of helium. Okay. So then we have found out that this container, it is now the unknown gas which was filled was helium. Okay. So this is how you make use of your STP conditions. We will take more numericals in coming videos and learn how to use it. But on your own you can go and try problem 5.11 of the unsolved problem of Felder, and it is in the same lines, and just go and try it. If you have a problem, let me know and I will solve it for you. Okay, so next we are going to study what do you mean by SCMH flow rates. SCMH stands for standard cubic meter per hour. Okay, so often in industries the flow rates they are measured at standard conditions. Okay, so all the flow meters, they have been calibrated to give you SCMH values. These are not actual flow rates. These are the flow rates if you bring your process gas from process condition to standard conditions. Then the flow rate which it will have, that is your standard cubic meter per hour flow rate. Okay, so keep in mind that this is not the actual volumetric flow rate. This is the flow rate the gas will have if you bring the gas from its actual condition to standard condition. Okay, so let's understand it using a example. Using an example, suppose I have reported a flow rate of 15 SCMH at 150 degree and 5 atmosphere. Okay, so initially it becomes a little confusing because I am saying that the gas is at standard condition, and again I am specifying another temperature and pressure. Okay, so don't get confused. What we are saying is that the volumetric flow rate at standard condition, that is pressure equal to 1 atmosphere and temperature equal to 0 degree centigrade. Okay, if the gas would have been at this pressure and temperature, then its flow rate would have been 15 cubic meter per hour. Okay, so at PS and TS I would have a volumetric flow rate or V dot S, that is equal to 15 meter cube per hour. Okay, but this is not the actual flow rate. Now, if I am measuring my flow rates in SCMH, then I will have to get my information for the actual flow rates. Okay, so there are two different types of information which you can get from these SCMH values. First of all, let's understand this, that you can calculate your molar flow rates using SCMH value. How? Let's see. We know that at standard pressure and temperature, the volume occupied by 1 kilomole of gas is 22.4 meter cube. Okay, or in terms of flow rates, if I am talking, then 22.4 meter cube per hour of flow rate will correspond to a molar flow rate of 1 kilomole per hour. Okay, so just by the unitary method, okay, 22.4 meter cube per hour corresponds to 1 kilomole. So 1 meter cube per hour will correspond to 1 divided by 22.4. So 15 will be 15 divided by 22.4. So from SCMH value, I should be able to calculate my molar flow rates by simply dividing whatever SCMH value you have by 22.4. What is the molar flow rate? You can calculate and see for yourself. Okay, so this is one information which you can get. Second is the actual flow rate. Okay, what you can get from it. Now, in order to calculate your actual flow rate, you will have to use your ideal gas equation. Again, I want to get rid of R. Okay, number of moles remain the same, because when you are bringing the gas from the process condition to the standard temperature and pressure condition, you are not making any change in the number of moles of gas, so it remains constant. So I am writing first of all the numerator, that is PV is equal to nRT at process condition, then the denominator is PS Vs is equal to nRTS, that is at standard temperature and pressure conditions. Divide these two equations, nR gets cancelled. Rearrange this equation for the actual volumetric flow rate, okay, and then just put the values. Fine. Here Vs is your volumetric flow rate at standard condition, so that's why SCMH value comes over here. Everything else you know. So you have calculated the actual volumetric flow rate using your SCMH value. Okay. So these are the two information which you can get if you have SCMH value. So in upcoming videos, what we will see is that how to use this information in order to solve any real problem. Okay, so keep watching my videos, and if you find it useful, please don't forget to like this video and subscribe to my channel. Thanks a lot for watching.